economic development in the world. So, which is a complex and integrated production chain. So that spans from primary agriculture to the mature food and beverage sectors. So this agriculture and allied sectors contributes approximately 12% of country's GDP for the fiscal year 24 and current prices and supports around 46.1 percentage of the population. So this agri-food industry is a strong and the complex, presenting a wide range of process and operational challenges. So to improve this agricultural production and the product quality and to satisfy the market demands of an ever-growing population, so the agri-food industry must develop some innovative and sustainable solutions. So as with all the industries, we know technology plays a key role in agri-food operations and decision making. So agricultural sector is also undergoing a digital revolution. So now you can see in all agri-related processes from machinery to the decision-making system through the use of robots, sensors, and cyber-physical system technologies has been widely used. And by using this integrated decision support systems in conjunction with the advanced internet networks and system, so the agri-food sector has a great potential for the radical improvement in terms of intelligence, efficiency, sustainability, and the performance. So this sector has been highly influenced by the technological implementation of the manufacturing sector. So currently we call it as Industry 4.0. So before going into our smart and digital technologies, I just want to take you to the history. Okay. So we just go through the history. As you can see, this is the transition of the agri-food from 1.0 to the 4.0. So we can see the agri-food industry has been evolving according to the technological development in the manufacturing sector. So this is growing rapidly after the industrial revolution of the 19th century. So during that time, we can see the advances in the industrialization of food processing, which has originated especially by the mechanization of systems and the use of a steam engine. So this period has been labeled as agri-food 1.0. So this 1.0 started with the mechanization of the system. So here comes the agriculture or agri-food 2.0 in the 1950s, which was mainly highlighted by the utilization of electricity. So therefore, here the solutions were focused on the electrical machines, which allowed increased production capacities. Also, this period has been remembered as the Green Revolution, which we all might be knowing, where synthetic pesticides and the fertilizers emerged. Then comes the Agri-Food 3.0 at the end of the 20th century, and it was marketed by the robotics and automation that operates in the field, carrying out complete work cycles in tasks such as sowing, harvesting, operation of semi-automatic and automated greenhouses. So, which had a great progress in the crop techniques. And currently, the agri-food industry is influenced by the technologies, techniques, methods, and strategies which is proposed by the Industry 4.0. So this period has been benefited by the cyber physical systems with application in the open food production systems and precision production systems. And some examples are like intelligent greenhouses, your robots, drones, smart sensors, wireless sensor networks. So all these are the examples of the revolution of the Industry 4.0. So this slide, you can see how Industry 4.0 influences the agri-food industries. As you can see, some of this. So starting from the crop management till the product reaches the consumer, so there is an influence of the Industry 4.0. As you all might be knowing, the precision agriculture, so wherein crop will be monitored continuously. So with that to the digital supply chains, and also this Industry 4.0 is influencing the national bioeconomy system based on this big data analysis. So now we'll move on to the title, which is the digital and the smart technologies. So before that, there is another way of understanding agri-food production system is by identifying the systems of collaboration that currently are applied to the agri-food production system. So we know the technological advances have been impacted by the way in which humans participate in the agri-food production process. Hence, through the history, producers have been benefited by the incorporation of specialized machinery, tools, and information and communication techniques. But the human participation prevails despite the technological advances. So, to understand this, there are the three type of interactions which we have to know that is could be implemented in the new products. So one is the human human and the human machine and the machine machine interactions. So human human interact collaboration, which is represented by the participation of humans without the use of any technology or the devices in the agri-food production system. Here, human is the main responsible for making all the decisions and actions. So about the food production system. So in this type of collaboration, the human can be supported by the other humans and the conventional machinery and tools. So this might be the agri food 1.0 we can talk about. And next comes the human machine collaboration. So this refers to the human interaction with a large variety of technologies and devices. So in the agri-food system, this type of collaboration is most used, like due to the variety of available technologies support the monitoring systems or automation of different systems. So the whatever we are using right now, that is the human machine collaboration. Like you can call about the use of graphical interfaces, tangible user interfaces, voice user interfaces. So all this comes under the human machine interaction. And the last comes the machine machine interaction. That refers to the autonomous systems that work in an agri food production system. That can be a robots and automatic systems which can sense, decide, and act without human intervention. So these types of systems are taking advantage of modern communication systems using like wireless communication that allow them to be able to interchange the information with the similar systems. Also, these systems can interact with the humans and learn from them. A quite simple example to quote in the mission collaboration is your AI. So AI can, it can decide, it can sense, it can act without any human intervention. So that could be a mere example of your mission interaction. So coming to the digital and the smart technologies. So here it can be electronic tools, systems, devices, resources capable of generating, storing, or the processing data. So it could be anything. It can be a software application, it can be a hardware devices, and it can be a communication networks. So that enable the data to be processed, stored, and the transferred. Okay. And smart products generally have a three core elements. One is the physical components, which can be a mechanical and the electronic part. And next is a smart component that consists of the control systems, sensors, microprocessors, data storage, software, and the user interface. And the last comes the connectivity components like your ports, antennas, and the wired communication protocols or wireless communication protocols. So that includes the connectivity components. So here the smart component or the smart technology connotes the products that are intelligent. So this implementation of smart products can be found in the different sectors. For example, automotive systems, medical devices, assisted living, so etc. And you can come across the names like in agriculture, like digital agriculture, agriculture 4.0, and the digital agricultural revolution. All these terminologies are refer to an approach aimed at making the food production more efficient. And this efficiency is achieved through the streamlined communication of high quality data and the use of current technologies like the Internet of Things, big data, artificial intelligence, and much more. Okay. So this optimization of food systems can achieve the social, environment, and economic goals such as the increased production yield, improved nutritional quality of the food products, and greater transparency, improved animal welfare, and the greener production. So these are the different types of digital technologies used in the agri-food processing. So here I have depicted the major digital technologies which is currently being used in the food process, I mean agri-food processing, but there are much more digital technologies which are, under research. So these are the digital technologies such as artificial intelligence, IoT, which is Internet of Things, blockchain, big data, robotics, and the smart sensors. So this technologies can be used with the entire supply chain from far or field to the fork. And the main objectives of all these technologies is to improve the productivity, reduce the food safety risks, and enhances the sustainability of the entire supply chain. So that is the main goal of the these digital and smart technologies. So moving on to the first technology, that is artificial intelligence. So many of you might be knowing about the artificial intelligence and how we are using it right now. But AI has the ability of the machines to acquire the knowledge and make informed decision by the processing data. Especially, this encompasses a set of technologies based on electronic devices, computer systems, and the robots. So that will enhance and improve the acuity, speed, accuracy, and efficiency of users' activity. And here the main goal of AI is to make computers, machines, or robot to be intelligent, which is akin to the human thought. Also, this AI should be able to easily identify things, recognize objects, analyze profiles, find solutions, make decisions, order the actions, predict anomalies, and learn and remember the next steps in the supply chains. So these are the functions which AI should do. And especially in agri-food processing, it can be used to automate the task like sorting, grading, and packaging produce. Like you can see in the fruits and vegetables, sorting and grading is more important for the monetary benefits and forecasting crop yields and detecting food safety risks. So this is the most commonly employed AI application areas in agri-food processing, and it can also be employed to mitigate the risk factors if any deviation occurs and improve the food security, um, and achieve the self-sufficiency while reducing the poverty and minimizing the hunger and preserving the natural resources. And next is the Internet of Things. So this is nothing but the integration of the sensors and actuators within the physical objects, enabling their connection through wired or the wireless networks. Here, the Internet of Things often utilize the same internet protocol used by the internet. So here, the concept is to connect the devices and the sensors to the internet to collect data on automated process. So this integration of IoT platforms in agriculture is mostly used in the precision agriculture or the smart agriculture, which terminology this terminology you might have come across. So that provides the additional data of the sources describing agricultural features such as the water, soil, um, humans, and animals. So, such as with more data of monitoring devices, this Internet of Things is quite applicable. And most IoT applications focuses on monitoring the temperature, traceability, humidity, color, and improving the sustainability performance. So this hold a significant importance within the vegetable supply chain, especially during the agricultural phase. And also this has proven the instrumental in optimizing your operational parameters like your pesticide and the water usage can also be monitored or it can be regulated using the IoT systems. So other parameters like you can go for the soil composition or crop physiology can also be monitored via the IoT devices. So next comes the blockchain. So blockchain is a very transparent digital ledger technology. So basically, this is a system which records the transaction and stores data in a more secure and the decentralized way. So this was developed basically in the 2009 and it has different types of the blockchain basically which is differing in the access and the control like you can call open, private or the hybrid blockchain. So depending upon the access and the control you can use the different blockchain applications. And the application of this technology has gradually extended due to its benefits in ensuring the food traceability, transparency, safety, and security. So, in many supply chains, you can just encounter this blockchain technology to be used from the growers or from the farmers till it reaches the consumer plate. So, this blockchain is quite commonly used. And next comes the big data technologies. So big data technologies is nothing but the a large, fast moving and a complex data which cannot be processed by the conventional or the traditional techniques. For example, we can take the National Climatic Data Center, which is a big data repository. You know about this National Climatic Data Center. And moreover, you may also come across the satellite imagery and meteorological information from Google and NASA. So all this data are the vast, diverse, and rapidly changing, but it cannot be processed using any conventional technologies, tools, and systems. So that cannot handle it effectively. So integration of this big data technologies would make them more efficient and can be made more into a structured way. So this integration of big data technologies and agri-food projects holds a significant importance in three different areas. So the first one is using the existing data, we can generate a new knowledge about it. And after generating this knowledge, so creation of innovative services and processes by the IT providers and software developers. And the last one is with the developed, with the created one. So we can go for the adopting the big data models linked to the information and communication technology, and we can build the factories of the future for the agriculture. So these are the three key areas where the big data technologies hold a significant importance. And the last is the automation and robotization. So automation and robotization is quite uh, hard topic. Like we all know, this digital technologies, especially automation and robotization, has enabled machines and robots uh, to perform the activities which was previously done by the humans. So this is basically introduced to reduce the drudgery and labor cost. So this is driving the development in agriculture and accelerating the transition to smart factories, and especially in agri-food processing, this robotics can automate tasks such as the planting, weeding, picking, handling, harvesting, etc., to improve the efficiency and to reduce the labor cost. So this automation and robotization we might have come across in the various processing, starting from the agricultural tools or agricultural systems till the food processing, like we might have come across the systems which has been integrated with the microprocessors or any other controlling devices, it might be integrated. So these are some of the smart and digital technologies which is quite commonly used in the agri-food industries. So here comes the application area in food industry. So where it could be applicable or how it can be used, what are the benefits of it, we are going to look into it. So first one is the smart design. So smart design is here you can go for the 3D modeling and simulations, and that could be the benefited in such a way like it can adjust the composition and packaging of the food products to the preference of the specific group of the consumers, or you can go for the digital twin of the products that can be developed based on various formulations or containing various ingredients. So that is the smart design. So in the smart design, so you can just design the composition of the food products and you can just see the what are the, I know, before even developing the real models, you can just go for the digital twin, and you can even go for the how the preferences or how the market fit or how the consumer study can be applicable for that product can be studied over there. And the next comes the production planning. So here the business plan, especially analysis of the business processes based on the data from the supply chain management or the data on the suppliers or the data from the sales point, financial data. So all this could be a study and it could be applied for the increasing the timeliness of the raw material supplies, more precise prediction of increases and decreases in the demand for the selected food products in specific places and even in specific periods of the year. So that could be done using the digital technologies by the production planning. And the next comes the process and the product optimization. So this, as a food technologist, we all might have come across this process and product optimization. Say in your UG or the PG degree. So whenever you come across a product, say whenever you come across a traditional product or whenever you come across any kind of product, the first thing will go for the standardization of the process or optimization of the process and the product. So in this one, You could use the machine learning algorithm, artificial neural networks, or computer aided designing. There is a CAD, CAM, and the product lifecycle management programs. So that could be used. So which increases the efficiency of the procedure related to the safety and also the quality of food products. And it can even improve the parameters of the production line, reduction in the cost, and improving the productivity. So those things could be achieved through this process and the product optimization. And the next one is monitoring of machinery and the equipment. So here with the use of sensors and the cameras or early warning systems based on the algorithms of decision trees and neural networks. So we can easily maintain the machinery to prevent the malfunctions and also the predictive maintenance of the equipment, improving parameters of the machinery could be done using the monitoring of the machinery and the equipment. And the last comes the smart supply chains. So once you make the product and once you go for the monitoring, all these things, so finally it comes about the supply chain. So here the RFID tags, so the radio frequency identification tags or the application programming interface can be applied to track the flow from material and the products and supply chain, and even you can track the storage in the real time to avoid the food waste, and the loss reduction could be done using the smart supply chains. So these are the vast supply, vast application areas in the food industries. Apart from this, there are so many application area which I couldn't depict over here. But if you take each and every step in the food manufacturing industry, so every step can be digitalized, or every step can be connected with the smart devices. So that is all about the application area in the food industries. So after this, we are just going to look into some of the case studies, so in which the smart and digital technologies has been employed over there. So we'll just have a look at the case studies. So the first one is IBM Food Trust. So this is a software, or you can call it as this is a blockchain based platform. Okay, so here this will gives you a transparent and traceability in the food supply chain. So this is especially used to track the journey of mangoes from the farm to the store shelves. So from that point of view, so this platform has been created, so this will enable you to identify the source of the food safety issue. For example, if you're transferring your mango from the, say, from the farm to the retail market or to any of the stores which you assign, so you can just say whether the temperature is within the desired limit, or you can just check whether any physical injury is over there or any mechanical injury is over there. So you can even quickly identify the source of food safety issue, resulting in the recall of the affected products. For example, if there is any food safety issues over there, so you can easily recall the affected products using this blockchain platform and even prevent the further contamination. So this tool has been effective in improving the food safety by enabling the quick identification, and also this is proven to be beneficial for the sustainability and reducing waste in the supply chain. So this also allows for the more efficient inventory management. So especially if you are tracking all these things, so this also allows for the more efficient inventory management and reduces your food loss due to spoilage or expiration. So using this IBM Food Trust, even we can go on for the creating the new business models and enhancing the trust between the different stakeholders in the food industries. So because just because it is quite transparent, so this will also gain a food safety trust among the consumers in the food industry. Okay, so but there are certain limitations in IBM Food Trust platform. So this small businesses may find it too expensive, even though it is sustainable. So small businesses cannot afford this platform to adopt in their systems. Also, this is still in its early stages, and the future infrastructure responsibility need to be built for this IBM Food Trust. So this is all about your blockchain based platform for the mangoes. And the next comes the ML in the food safety. So ML is nothing but the machine learning. So here the automatic food safety early warning system has been developed in the dairy supply chain in Netherlands using the machine learning. So here they have investigated whether anomalies in drivers of change and the indicators which has been selected by the domain experts can be used as an early warning sign for the food safety risks. So the initial step is to identify the drivers and the indicators, and the next step is to identify the data sources. So the indicators has been already given by the experts. So based on that one, they'll be identifying the data source and the quality assessment will be done for the each data source. After that, so there is software that is known as a KNIME. So creation of this workflows will be done using the automatic data retrieval, automatic data processing, and the automatic integration of your collected data from the different sources. After that, based on this data which is retrieved and the data which has been processed, so anomaly will be detected. So whether any deviation is there in the data or any process. So based on that one, so it will report automatically and will also send automatic alert to it. So then there comes a Bayesian network model which was developed to all the data of the indicators and the food safety reports in the liquid milk when anomaly has been detected will be given. So this is all about the machine learning in the food safety. So apart from this, machine learning has much more applications. As I know, so machine learning can be used to predict the, process forecast can be easily done using the machine learning. For example, if you feed the data, so test data, if you feed, so it could be predicting the forecast of the process. Say if you're frying, so the process could even predict the oil uptake of a certain product, or even it could predict the browning reactions of the certain product. So that also could be predicted using the ML. So here comes the digital twin for monitoring cooking. So before going into this case study, let me just get you what is digital twin. So digital twin is nothing but the, so initially what you need to do is you need to prepare a virtual representation of the product, processes and facilities. So that will enable us to design, simulate and operate their physical counterparts. For example, if you want to develop a food product which is useful for the geriatric patients, okay, I mean elderly people, okay, so elderly people, you just wanted to have a food which is customized just for them. So initially what we will do, we'll just buy all the ingredients, we'll make a different composition, we will just go for the different composition and optimization part will be taking place. But no, here, you have to create a product virtually. So, here you have to create the product or the process and the facility virtually. You have to create it and you have to simulate the process. For example, if you're going to prepare a bar, okay, so nutritional bar, then you have to simulate that process and operate their physical counterparts. Then you can go for the actual preparation of this nutritional bar which you're talking about. Okay. So here, especially this case study focuses on the monitoring and the predicting the cooking of French crepe. Okay, so crepe, we can call it as a pancake. Okay, so that is what French crepe. So here, the digital twin has been made, okay, using the neural network, which is trained on over 4 lakh simulation data points. So here already the digital twin has been created, and this developed digital twin can replicate the cooking process of crepe by using the data from the IoT sensors. So here the IoT sensors will be there. So which can give you the monitoring the cooking parameters like your temperature of the frying pan and the weight of the batter. So everything will be fed into this IoT sensors. So from this IoT sensors, digital twin will be acquiring all the data. So based on this information, the system will calculate the real-time parameters. So which will describe the state of the grape. For example, if the temperature is around 150, say 150 degrees Celsius, so at that time, what is the color change in the pancake or color change in the crepe? What is the weight loss in the crepe? How much moisture has been evaporated? So everything can be simulated using this digital twin. And this also allows the system to provide the information about the doneness of the food. So once the crepe is completely cooked. So that can also time duration for that crepe to complete the cooking process also can be, you can simulate using this digital twin, and it will estimate when it should be turned over, like when it should be flipped, when it should be turned over or removed from the pan can be assessed using this. And in this case study, especially this digital twin can accurately estimate the properties of the creep during cooking in real time with absolute percentage error of less than 5%. And this, as I said, this uses the information provided by the IoT sensors, which can be extended for use in the smart kitchens and also in any professional kitchens. We can just employ this one. So this is all about your digital twins for the monitoring the cooking. And the next comes the automation. So this is my favorite part because this study was done by myself during my PG research program. So here the automation in the paneer processing. So here it employs the three units, wherein the milk heating tank, coagulation tank, and the pneumatic pressing unit, which was controlled by the controller unit and the programmable logic controller. Reach the third point, solenoid valve will be placed, which was signaled by the controller unit. So this controller unit controls two units, which is nothing but the heating unit and the coagulation tank. So once the milk get heated through the solenoid valve, that will be poured into this coagulation tank, wherein all the coagulant is up in the coagulation tank to facilitate the coagulation process. Okay. So what will happen once the milk get poured into the coagulation tank? Timer fix your coagulation needs some time, right? Already timer has been set. Happen the timer snell the solenoid valve to get open so that the coagulated mass unit was by the PLC, that is a programmable logic controller. So here the compressed air will be released from the compressor, which will flow through the FRL unit to the solenoid valve and the of air into the pneumatic cylinder at set pressure value. And here the pressure was varied using the pneumatic pressure switch. So as you can see, heating tank, coagulation tank, and the pressing unit. Pressing by the pneumatics cylinder was by the compressor, a compressor, and see the controller unit and PLC system, which was also placed over here. Cost of the unit was around 44,000, and it operates machine, which was 18% less, which is 18% less efficient the semi-automatic units like controller unit and the PLC. See, automation and the also a research which is done by myself during my PhD program. Here, uh, pressing and the de-oiling, both the process was done for traditional fried products. So here, this is a dual purpose machine wherein a pressing was done for the into a circular shape. So that has been done initially. So after the frying, deep fat frying. So we all know deep fat fried products have the excess amount of oil in it. So to remove the oil, so de-oiling process has been designed. So here the pressing and the de-oiling is automated with the same machine, and it was controlled by the Arduino programming. So here the Arduino programming has been employed. So this Arduino board will act as an interface to power the solenoid wall. So here this Arduino was connected with the push button switch to start the pressing operations. So once this is started, so limits attached to the plate and the sample platform to detect the position of the plate And these switches will ensure that play within the defined limit and actuate the system according to the position of the plate. And, and there is also potentiometer is provided, which is a variable resistor system for the rotatory movement. So by addition, it provides control of the time. And here we have we have assess the capacity of the machine, we fractioners and consumers engagement, and enhanced cybersecurity framework could be done for the improved infrastructure and sensitive maintaining sensitive data, and also the growth of interdisciplinary research combining the food science, data science, engineering. So all this interdisciplinary research could be interrelated to some of the references. Thank Hello.
Yes, ma'am, audible. Audible. Yes.
Have any queries or if any
Participants, if you have any question, you can unmute your mic and ask. Anyone? Okay. Ma'am, there is a message from Vaibhav Patel. Explain a little more about blockchain.
So yeah, so blockchain right now all supply chains, major companies supply chains has been adopted blockchain. So just for the better traceability and the transparency. So you can see, as I said, if you're transporting something like take an IBM food trust. So that is an example of the blockchain based platform. So if you're transporting from the farm to the market, so you need so like where it is reaching, where the thing it has under the mechanical damage or any any physical injuries are there, so you need to trace about it. Or you might have quote a very simple example. For example, you might have come across that Maggie lead, I think lead has been mixed Maggie masala, we all come across, right? Recall program has been initiated for traceability and transparency. So that IBM Food Trust has been using the this platform only for the mangoes, but that is a great for adopting products also, starting from the farmer till it plates on for the tracing and the transparent way. So it will more trust in your product or more trust in which you create. So that is the application of blockchain. I think this is enough.
Yes, yes. He said thanks. Anyone else? From Radha, thank you for the informative session, ma'am. Okay.
Thank you so much.
Okay. Now I may invite Dr. D. Tiruchelvam, head of the department, to propose vote of thanks.
Thank you, Nisha ma'am. Good evening to one and all. As we conclude this enriching 5 days journey of PDP, I, Dr. D. Tiruchelvam, HOD of Food Technology Department, Manakula Vinayagar Institute of Technology, Puducherry, consider it as a honor and privilege to propose vote of thanks on behalf of our department. First and foremost, we consider our gratitude to the Lord Almighty for His divine grace and guidance in making this professional development program, Food Horizon, pioneering nutrition, sustainability, and processing trends, a resounding success. We express our heartfelt gratitude to our esteemed principal, Dr. S. Malarkan, for his constant encouragement, visionary leadership, and for providing us with the platform and resources to conduct such type of high caliber academic events. A special word of thanks goes to our experts who shared their profound knowledge with us over the past 5 days. Dr. Syed Ishan, Assistant Professor, Department of Food Technology, Vinyan University, for setting the platform with insights into smart and sustainable food packaging systems. Secondly, Dr. J.S. Divyasri, Assistant Professor, Department of Food Technology, Rajalakshmi Engineering College, for clarifying the complexities of HACCP and global safety standards. Then, Dr. Rita Narayanan, Professor Tanuvas, for her enlightening session on the power of fermentation and gut health. Dr. Priyadarshini, Assistant Professor, Department of Food Technology, Rajalakshmi Engineering College, for her detailed discourse on additive manufacturing in food technology. And today's expert, Dr. S. Sivaranjani, Assistant Professor, Department of Food Technology, Ganpat University, Gujarat, for bringing us the cutting edge and digital and smart technologies in food processing. Your expertise has truly broadened our horizons and inspired us to look at the food industry through a lens of innovation and sustainability. Then, our participants are the heartbeat of this program. We thank the faculty members, researchers, and students from various colleges across India who have joined with us online for the past 5 days for this PDP, enriched the discussions and made this learning experience interactive and vibrant. Then I thank our Dean Placement, Dr. Jayakumar, for providing us the Zoom link for the successful conduction of this program. The success of
Thank you so much, sir.
Thank
With
you.
this, I'll conclude the session. Lastly, my sincere thanks to all the participants. With your enthusiasm and with your involvement, only this PDP program is a great success. Thank you so much, all.
And
Thank you,
we will, our organizers will send you the feedback form. Please fill it and send it to us so that we can process the certification certificates. Thank you.
Yes, sir. Also, the session PPTs will be shared in the group tomorrow.
Okay, ma'am. We will conclude. Thank you.
Yes, sir. Thank you. Thank you, sir.